So, welcome to Microservices at University Council, joint course with the University of Douala, Cameroon. And we are in winter term 21-22, and it's our 7th lecture. Oh my God, it's almost half the time. Very good. Okay. So today is a complicated one. Last week I was telling you a lot of how promises work and concurrency issues work in TypeScript and in Nest and in Angular. And actually the Nest thing is the complicated stuff. And well, I'm not sure whether I did a good job on this. It was an awfully really complex explanation, and I really think it should be simpler. So I will try to improve on this next year. Still, what you should recall is that, well, there is this event loop in the nesting where messages come from the outside, for example, post and get HTTP requests, and those are run one after the other. So this event loop takes one event from the queue, some request from the queue, and then it works on it. However, until you do something which is input-output operation, and in our case, until you do a database operation, either a query or an update operation on your database. Then you have an asynchronous operation where you await for the result of that one. And while you are waiting for one database operation, Nest.js will go back to the event loop and start working on the next thing. So it might do multiple requests in parallel. So, and parallel is no, there is just one thread in Nest.js. It does this request or that request. However, as soon as you hit an await for a database operation, that current request is stopped and put to a side, and a new request is going to be worked on. Which at the end means that you can have multiple, well, requests to your database that are executed concurrently or in a certain order. And this is, there is a lot of timing issues on that, and we need to deal with that in our design after all. And that is pretty tricky to teach. And I will do some more of this database design stuff today. And actually, it's not my real expertise, so I hope that Sebastian will help me on that. There is a lot of design and pattern and ideas and tricky things that go into this problem, because it's actually a very tricky problem. And I have set up this, well, design of our application. On the left hand, there is the warehouse. On the right hand, there is the shop. And actually, we will have multiple warehouse clients, so multiple users that have started our Angular app in their browsers, and they are executing things in parallel. They will send commands and queries to the warehouse service, and I actually should change the color of these two things here to be blue or something like that to meet our event storming ideas. I'll come to that one later. So, for example, there will be requests like product stored or pallet stored, I think is the name that we have here, and query for all the pallets of the data house. So the warehouse service is actually the Nest backend that we run. And that one actually, well, thinks about the commands coming in, executes them, and stores them finally in the warehouse database. and we will soon set up a more complicated data model within our warehouse. So far, our warehouse just stores the events or commands that come in. So we just have an event store. We will do more here soon. So in our week, there should be, no, we need a new one. Shop. This GUI event roaming, yeah. This one? No, this one? No, this one. I like that one. Yeah. And I enlarge this a bit. No, I first do it very small. So this is the overall workflow of our application, and we are currently have done the warehouse user interface, and we are about here. So focus on this one here, and I just enlarge this a little bit. So this is the very first workflow, and I just even enlarge it much more, where the warehouse is done there, the store task, and we add a palette, and we go send a command to the warehouse. The warehouse actually set up data structure. We do not yet really do that. However, this is coming soon. And finally, the warehouse sends an event to the microshop, telling the microshop that a new product has arrived and that it should be put in the online store to be sold. And actually, we are about to send this orange message today. However, last week we were starting to set up the data structure here on the right-hand side. And this data structure is really, really simple. However, we will actually deal with this today a little bit more. And somehow later on, there will be a Kali customer. Let's go on that one. Kali customer will actually order some shoes via graphical user interface that still needs to be programmed. And then we will have a data structure that looks like this. Where we have this red shoes, and there is an order which is executed by Kali customer. So we have a more complex object-oriented data model, and we will try to deal with this data model in our shop database. So the shop database will have more information than the warehouse database by now. The shop database will have the event store, which is the events that have been sent to the shop service, and in addition, an object-oriented data model. And this object-oriented data model is going to answer certain queries that you can send to the shop service. For example, you can ask for, I would like to have the list of all my customers, or all the customers that did an order within the last 4 weeks, or something like that. And for such a query, this new data structure here is perfect, because we'll have a collection of customers, and we can answer that query on that with the help of that information. Okay, there is some more things that we need to discuss about. So we will finally have the warehouse and the shop, and they will have both their own databases. We will have a warehouse database and a shop database. And those two, applications or services are going to speak to each other by exchanging some events. So the product stored event is sent from the warehouse to the shop, and from the shop to the warehouse we send, for example, order placed events. And we will have some more things like pick task has been completed from the warehouse to the shop, and so on and so on. So finally, the we are at a very critical design problem for microservices. And the problem is that we have two, models, two, databases containing data, and the information contained in the warehouse database and in the shop database is somehow overlapping. And for example, those two microservices have to agree on how many red shoes do we still have. So the warehouse first actually says, oh, there's a pallet with shoes, there's a pallet of shoes, there's a pallet with red shoes. This sums up to 42 boxes of shoes. And then it tells the shop service, yeah, this is the number of shoes we have. And then the shop service is starting to sell shoes to some customers. And each time an order comes in, the amount of shoes that are still available is dropping by one. So as Kali customer buys a pair of red shoes, it dropped the number of available shoes from 42 to 41. However, the warehouse does not yet know about that. For the warehouse, there are still 42 pairs of shoes. So now the order placed event is going to the warehouse, and the warehouse says, oh yeah, we have one sold. Well, actually, I'm going to count or to decrease the number of shoes that I have on stock as soon as I send the box out of my door. So there is some, and there are more orders coming in here, and there might be more pallets coming in here, and all of those actually affect the belief of the warehouse and the shop of how many shoes are still there. And eventually, that's the point that we have. When we are done by handling all these events and there are no new requests coming in from the outside, those two services should finally agree on how many shoes do we still have. And that's a tricky problem. So actually we have a data model living in the warehouse, a data model living in the shop, and those data models are somehow overlapping. And what you need to do is to synchronize these two data models. And actually, software engineering does not really yet know how to do this. It's pretty complicated. There is a whole series on workshops which is called bidirectional model transformations, BX. If you would Google for that, you will find tons of paper addressing this kind of problem here. And it's really hard. And in the book of Microservice Patterns by Chris Richardson, they actually said, oh no, that's not a good idea to have a model on multiple microservices that overlap, two models that overlap. Don't do that. He says, what you need to do is a CQRS pattern. You need to do CQRS is Command Query Responsibility Segregation. Hey, I love it. And so what he basically says, if you have some shared knowledge, like a number of shoes that are still there, you put that on a dedicated service who is managing the product. And this service is the one and only service who does changes to the number of available products, and where you do write operations. And then if there are other services who want to know or which want to know about this information, the number of shoes, they shall create a view. So the central managing service is sending out events to the other services in order to inform them about changes to this. So in our architecture, it would mean there's some component in the middle here where I have done this event broker, and there would be another service which would be the product service, and that would have its own database. and that would be the service who is doing all the changes. I don't like this idea. So Chris Richardson is the most renowned expert and designer for microservices, and I think he's plainly wrong. And well, so you may read the book, listen to my lectures, and then come to your own decision. So what I'm going to teach you today and next week is very experimental. It's not yet established knowledge or science. However, actually, we will evaluate the ideas that Sebastian and I were developing the last 2 years with the help of your applications, whether this works actually in practice. And we are really looking forward for your solutions, whether this actually works or not. If this is a total failure, we will actually, go back to the book of Richardson, and next year we will teach the other stuff. So please help me to make this a success. So, there is actually a very, it's not a simple idea. However, it's the core idea that we have is, well, if you have two services that are collaborating on a certain thing, you should actually organize the responsibility for certain steps of your workflow with the help of a workflow. So you should have a workflow. We did that. So this is the reason that we came up with this workflow description at the very beginning of this course, because this actually tells you at which point in time, which of the two services may do a write operation that affects the number of products that is available. And because we have this workflow, it is very, very clear at which point is time the warehouse may change the number of shoes that is available, and at which point of time the shop may change this number. And this is no longer, so it's still a little bit the CQRS idea. However, our workflow hands over the token of changing this information from one service to the other. And this is clearly beyond what Richardson is going to tell or proposing to implement these stuff. So it's, I think the idea is a step forward. And the other thing is that we use a clearly event-based system so that these two services are communicating just via the events, which is also an idea that Richardson actually proposes. And however, we have the idea that handling these events, or these events need to be designed carefully. And there are two event sourcing laws, and I don't know whether I have this somewhere here. No, damn it. So where is this? Here it is. Let's have a new slide. Event laws. Let's have just event laws. It's not really event sourcing anymore. Events may come multiple times, and events may arrive in any order. So this is already a discussion between Sebastian and me. So why is this the case, actually? Events may be received multiple times. And actually, when we are going to implement this, I will point you to the situation where this actually may happen. And then they may arrive in any order. This may happen easily. And for now, we just design our event handlers in a way that they address these two problems. And later on, so probably next week, we will see why this is a very helpful idea. And it's actually hard to, well, construct the necessity for these two laws in advance, because actually you could achieve an event-based system where events are arriving only once, and events come in order. Actually, usually you would use an event broker like the Kafka system or MQTT or AMQ, or how this is a RabbitMQ thing called? AMQP. AMQP. There are multiple systems, middleware systems, where you can hand over your events and they guarantee unique delivery and in-order delivery. That would actually, well, solve this problem that we have here, that you can rely on events arriving only once and arriving in the correct order. However, these systems are hard to well, operate and to set up. And we decided for this course, no, we are not going to do that. And actually, well, having this event broker in the middle is still not really a piece of cake to really ensure that you do not see an event multiple times and that they really come up in the right order. And from my point of view, as soon as you are aware of this problem, they may come multiple times, they may come in any order, and you prepare for that in your application is going to be much more robust and independent of mechanisms provided by the event broker you use. And actually, for this course, we will be able to even omit an event broker. We do not need one. And this will, well, somehow facilitate to set up our system and to test our system and to operate our system. And that's basically the idea. So here's our service. I have started it. We already have the no? Do we have it? Where is it? Here it is. I have the warehouse front-end spec running again. Actually, I would like to show you the other one again. So we go for the shop backend again and run that one. I have started Cypress. I have started the warehouse front-end. I have started the warehouse backend. I have started the shop backend. All those four systems are running. And the shop backend test is working. And it's all green. This is what we achieved last week. And so I'm fine with that. And let's have another look at this thing. So here is the Cypress, the warehouse front end, warehouse back end, and here is the shop back end. And I'm sorry, this is going to be very, very small the rest of the week or the rest of this course. And there will be even a fifth service coming up soon. I have no idea how to avoid this. I put this down because we actually do not really need to see this in detail, and let's go rid of these. Yeah, because we want this one only one, and there is this warehouse front end spec that is the test for the warehouse, and we will have a look at that one soon. And we will have the shop backend test. That is the one we are currently looking at. Shop backend test. The shop backend test just tries to contact 3100. That is the backend of our shop. And then it does a reset on that one to just put it in a state where nothing, where all the database is clean. And then it does a post request to send an event that there is a new product stored. And I don't like the block ID I gave that. I'm going to change that soon. Yeah, no, we could let it like that. Yeah, we will just first go on with this one and then change it. And no, not that one. I wanted to give you this one again. Let's go up here. So what this backend test is doing, it sends this orange sticker to the microshop. So we are actually in this shop backend test, sending an event to the microshop. And come on. So the event that we are sending is a product stored event. It has a block ID. I'm going to change that soon. It has a time 11:04. No tags. The payload is product black socks, and the amount is 10. And so this thigh thing here is the Cypress object that provides us with access to the Cypress operations. It provides you with a wizard operation to wizard a web page and a request operation to actually send a post request or a get request or any kind of request to our backend service. So usually, if you send a request, you need a wait in order to handle that request. However, Cypress uses a slightly different, so it doesn't use promises, but chainables, whatever the difference is, in order to handle these things. So the request here is answering you with a chainable. And you can actually do pretty much the same thing with a chainable that what you could do with a promise. However, they are not ready for this await thing. And what you do is you do a then. You provide an operation that is going to be called as soon as this request returns. And this operation is provided as a lambda expression. This is the blue stuff down here. And you say, oh, please, the response that you get back from this post here is a parameter to this lambda here. And in the body of that one, which is here the curly braces, there you put the code that is going to be executed as soon as this request returns. It's basically the same thing that you do with an await and the code that is after that await. However, this is the old-fashioned syntax that you used before the await was available. And what you do is you ask the response for the body, where the data is actually contained. And this should be, for example, a JSON object. And then you say, okay, I expect that the body is a product that has a property black socks and has an amount of 10. So you expect something that the payload is going to be returned to you. And that's the first thing that you do. So we send a product stored event and for black socks with 11:04. And then I said, okay, you need to prepare your application to handle that the same event comes in multiple times. In order to prepare ourselves for this, we just send the same event 2 times. And then look whether our system is dealing with this correctly. And so I just do here, this is the very first, then do a post request. And down here, I just do the same request again. Again, product stored black socks 11:04, and just copy paste this and run it again. And expect the same response. However, if I do a query on the database later on and ask for how many black socks do you have by now, I want this to be still 22. Well, actually, no, I want it to be still 10. So actually, I have changed this to 22 here. However, this is for debugging purposes. This is an event with the same block ID at the same time, so the second one shall be ignored. And the block ID and the time are very important for our design. And this comes a little bit, well, arbitrary by now. We will actually use the block ID to allow events for different block IDs to arrive in any order. And that is the other half of the design of the event laws or event handling laws. Event handling laws is much better. And so, yeah, sorry for this complicated thing. So let's have a look at go away, go away, go away. No, you are all wrong. Go away. It's all the very wrong one, I think so. And let's have a look on. We need an app controller. App controller, and we need that one of the shop. Yeah, love it. So the post request, we send it to an event, I think. No, yeah, host localhost 3100 event. So it will actually hit this operation here, where it comes in, and it says, yeah, Microsoft App Controller post event got. And it should be somewhere here, and I can't see it anymore. Perhaps we should restart that to see this. However, this will be very small anyhow, and we probably can't read it anyway. Still, let's abort this and restart that. npm start. In the shop backend here. Yeah, and have a look at this very small thing. And yeah, they put up my picture and picture to the top right. That's great. Shop backend is running on port 3100. Great. And let's have this test. Put it to the side so that we can actually see a little bit here. Have a look down here. I'm going to restart the test, and then there is a lot of things going on. And actually, I put that one up a little bit, and let's have scroll up a little bit what's going on, and it's actually much too much that is going to happen. So it says Microsoft App Controller post event got product stored black socks 1104, which is actually this statement up here. And then it calls the app service. Actually, I could get rid of these because there's too much messages. Let's have that one. Handle event. So this is the controller is just deciphering or decoding the URL request and decoding the body and provides it in a JSON format to us. And then I actually do this handle event. So the service is where the logic lives of our application. And the handle event then does look for what kind of event has been arriving. So it's a product stored event, and he knows that this event is going to be forwarded to our model builder service, where our database handling operations live. And so we go for handle product stored. And that is what we were programming last week. And last week I was using a transaction at this point in time. A Mongo database transaction in order to make all the operations atomic that I'm going to do now. And actually, Sebastian was not happy about that. And he says, well, you are using a Mongo database, and the Mongo database has different collections. Well, it's actually not designed for this transaction thing. If you use a relational database, relational databases have a long history in providing very sophisticated transaction mechanisms for you. And the Mongo database is a NoSQL database. And they said, oh, no, you do not need transactions. So We do not really know it, but there is a good chance that these transactions have a very poor runtime performance. And the general design rule is don't use transactions. Get rid of them, don't use them. And I was asking Sebastian, how should I avoid these? And we were thinking about this. And a little bit later, I found a workaround where I actually do not need a transaction, and we both are happy with these now. And so what we do is no more transaction, but we go for the store event operation, where we look at the build event model. So the build event model is the collection in our Atlas database, Mongo database, where all the events are stored and managed. And actually, I have this collection solely for handling duplicated events and events that show up in the wrong order. So the main purpose of this build event model is, oh, please let me know whether I already have received this event before, and or if I have a newer version of that event. And so that is what the build event model is going to help me for. And this is a new view for this build event model, because in the warehouse database, actually we only had a build event and nothing else. However, in the shop, we have this object-oriented data model that we are going to build in the next steps. And therefore, the build event model becomes its main purpose. And we will have discussions on this design between warehouse and shop during the course in the next weeks. So the build event model for now has the main purpose is, let me know whether I already got this event or not. And so what I now do here is find one and update with a filter, which is just the block ID. And if I do find this one, I do an update, which is, oh yeah, I do set the block ID, nothing else. And if there is no event with this block ID yet, I do an insert, which is achieved by this upsert true information here, which is the third parameter to the find one and update operation. And then I do this $set on insert. So this is only executed if I do an insert. If there is no old event with that block ID, and I set the time to the empty string. So what I actually do, if this is the very first event concerning black socks, then I will create a placeholder, an object for the block ID black socks, and with time is an empty string. And this is just to ensure that my database actually contains an event with this block ID, because in the next step, I'm going to do a find one and update operation without upsert. So there's no upsert here. And I say, okay, this time I'm looking for an event with this block ID. And this is going to work because I know that I have just inserted one to the database with the statement above. However, in addition, the time of that event shall be less than the event time, the time of the new event that is just arriving. So if this is the very first event for black socks, the first statement will create a placeholder event with time is an empty string, and empty string is less than any other string. So this thing here will be true, and we update the event that is in our database by the event that has been sent to us or passed as a parameter. If there is, if we send the black socks 1104 event the second time, this thing here will not insert a new event. So the set on insert is not going to be executed, but we still have the old Black Sox 1104 event in our database. So this is actually not changing anything. And this one actually says, okay, there is a Black Sox thing, and the old time of that one is 1104. The time of the new one is also 1104. So less than is not going to be true. And so this update operation is going to fail. We are not storing this new event into the database. And actually, this helps for two purposes. If I receive an event with the same block ID and the same time twice, I'm going to ignore the second one. And if there are two events that actually says there is new Black Sox and the block ID is actually the palette ID here, I think so. No, this is new Black Sox. And there was a message with timestamp 1104, and now comes a message with timestamp 1102, which should have been earlier, but I received them in the wrong order. I says, okay, they are in the wrong order. I already have a new event, so I'm ignoring the second one. And this has quite some implications if you handle this way. And so I spent a lot of time to explain this to you. I hope that Sebastian is fine with this information. Yeah, he says thumbs up. And however, we will revisit this implementation again and again, because this is really a tricky design issue that I address with this kind of storing events in our schema that are handling of block IDs and let then event times. Okay. Pooh, that was a complicated one. So let's go back. Yeehaw. So this store event is going to give me an access flag whether it actually did store the new event in the event store, or whether it says false if if this event came multiple times. So if this is the second occurrence of the same event, for now this is what I'm handling here. And so store success. So how does this work? Let's see. We return. So yeah. Let's have a look at that one. So this new is true in the third parameter actually says. So usually this find one and update would deliver the old object to you, because the new object is the one you know about, because you know the write operations. However, you can set this new flag, and then you the return of this find one and update operation after an await will be the new object. So, and this is important for this find one and update, because this will deliver a new event only if this condition, the filter condition here, works. So if the new event time is greater than or greater. If the new event time is greater than the old time, or if the old time is less than the new time. Okay, and then the new event which will be returned. Otherwise, this operation, if this filter fails, new event will be null or undefined or whatever. So what I can do is I can compare new event to null, and therefore this is true only if this operation actually did change my event store, if the new event actually has achieved past all the conditions and were going to the event store. Okay. So handle product stored. If success, so then yeah, we should actually handle this. And so here's a bug that I became aware of for yesterday, and I said, okay, let me leave it in there because it's a learning chance, a good chance for you to see how you should implement that. I hope that I'll be able to solve this bug during the session today. Otherwise, I will do it for next week. But for now, it works a little bit, but it's not the final solution. But we can actually study the problems very good on this one. So I create a product patch which says the product is the block ID, the amount, so it's black socks. The amount is payload amount, which is actually 10 for this very first session that really works. And so then we do a store product. So why do we do a store product? Yeah, I know that. Store product. So my first idea was that on the warehouse side, we have a list of pallets. And these pallets have different products. So later on, I will have a product object for red shoes or black socks at my warehouse. And then I will actually sum up the available number of red shoes or black socks on this product object. So the shop is not really interested in how many pallets I do have because it doesn't care. The shop just needs to know how many shoes it has or how many socks it has. So the shop says, no, I do not want to know about pallets. Please just tell me whenever new socks or new shoes come in, I have a single object where I sum up the numbers directly. And this is a very bad decision. But we go through it and then we will see what are the problems and then we will discuss how we can solve that. I love this idea. Okay, so what I now do, I do find one and update on a product model. Hey, products model, did we have that last week? Yeah, we have that. We've had that, yeah? Okay, so the products model, let's have a look. It should be up here. I have some more by now, but this is actually a Microsoft product. It has a product, an amount time. This is for debugging purposes. So it tells me what was the last time when this amount has been changed. And there is a price that is going to be that later on when Sabine Sales is going to put the product online. And actually this line here, line 14, is actually new. You need to add this because otherwise setting a price will not be stored in the Mongo database. But you may omit this required true because no, it's an optional thing. So, but you need to enhance your MS product with this. Hey, I've learned that one. Okay. So this is a product model. So this is another collection in our database. So we have a collection of events and we have a collection of products and we will have another collection of customers and a collection of orders later on. And what we do now is we look up the product, black socks, for example, and if it's not yet there, we do an upset. So we will insert a new object. And for this product, does this really work? Who is actually setting the product attribute down here? No one, is it? No one? That's bad. Well, for some reason, I named this. This is the first product. Is the name of the variable. And so that should be new product or something like that. And it's the thing that had these three attributes: product, amount, and amount time, and price, actually. And for the amount time, I do a set. And for the product, I don't do anything. That's not good. It might be a bug. Yeah. So let's fix that. Let's have product becomes product. Yeah. Our part of the homework is to explain which product means which product. So this is the field of the object that is going to be updated. This is referencing the variable up here, and this is a field of the object parsed as a variable here. And let's change that one. New product data, something like that. Then it becomes a little bit more clear. Yeah. So that should improve the thing a little bit. Yeah. Okay. So why did it work so far? I'm not sure whether it works. So however, it says console.log. And we should find this here with builder service store product. Builder service store event. That was an operation that comes from here. So that was this one, builder service store event. Block ID times tag black socks. Oh yeah, that's not good. That is the creation of the placeholder. So let's get rid of that one. And then it says builder service store event line 62. App controller post event. Damn it. Yeah, so we are lost. So that's actually already a new event coming in because we are in an await. Probably. There is this product service store event line 62. Come on. And it says, okay, black stocks 1105. That's already the second one. Come on. Damn it. 56. Ah, there's 62. Here it is. That should be, yeah, and that's 1104. Cool. And it says black stocks 1104, and the amount is 10. And that is the event that is on. And then there comes builder service store product, which is the thing I was discussing with you that does this increment and set operation in the products model. That's the important thing here. So builder service store product says I'm going to store a product black socks that was working. Yeah, it was working somehow. Amount is 10 and amount time is 1104. Great. So that seems to work and is fine for now. And I just restarted the thing by storing my thing. So we should actually rerun the test in order to get fresh output here, and then we can go on discussing the thing. So this is still line 56, still line 62. So why is this still telling line 56? Who cares? That should be away, shouldn't be? Builder service line, oh no, 56. Okay. No. Am I right? Builder service store event line 56. Builder service store event line 56. I just put that into. I was scrolling up too much. Here. I'm not sure. Yeah, here it's okay. This is 62. That is what's actually stored. Then there comes a store product. It's all fine. And then there comes a second event with 1104. We send the event twice. And here the amount is 22, but this is going to be ignored because it's the same block ID. And so the builder service store event line 62 says null. No, we didn't do that. We do not really store the event because it's a duplicate one. So we deduplicate the thing here. And so the app controller post event is now 32. Damn it, that didn't work. So why is this wrong? This is 10 plus 22, though it was actually doing this editing stuff. There's something wrong here. No, sorry. That's bad. So the deduplication didn't work. Okay. I stop this one. And I do an exit to get rid of that window. Just make this a little bit more. I stop this one. And get rid of the window. So this is a little bit more overview. And I'm going to stop this one. Yes, please. And let's get rid of this. And I do... Come on, what don't you understand? Microsoft Backend. No. So where's this npm start? So why is this not in here? npm start. We restart that one. Okay. Should we have this again? Yeah, I think we should. There was a reason for this, and I want to have it here. So let's rerun our test and see what's actually in the output, and then we will have a discussion on this. Okay, yeah, here we are. 1104, 10. This is the app controller thing. Then there's the builder service line 56 thing. Yeah, I have time, which is actually 0. So this is actually the empty string, though this is has been just created. Then we do service store event 62. We say, yeah, we have an amount of 10. And we create the store product with 10 and 1104. That's great. And then we do our app controller post event. We do the again 1104 and the black socks. And this one should be ignored. And the line 56 says, yeah, I already have 1104 and I'll leave it there. Could you speak to this guy? Yeah. I got the door. And there's someone who's calling me during the lecture. That's bad. And 56. So I'm a little bit lost. Okay, so yeah, so this installing a placeholder didn't affect the 1104. That's cool. Line 62 comes up with null. Great. Yeah. No, that's cool. And then there is, it's all right. It's great. So store product is actually not called at all. I love it. It has, the store event has actually said there's a null. And so we actually didn't do anything about the store product. This was so store product, handle product stored. So store success was null. We didn't go into this thing. Nothing happened. We are fine. and we need to go for the shop backend test. So we repeat the post, nothing is going to change. And so we expect the amount to be still 10, and that has worked. Great. And then I do send an update, another one with 11:05. And that one says, okay, here comes 32 new black socks. So we have already 10, we get another 32, it should sum up to 42, which is always a good solution. And so here comes Microsoft App Controller post event. Great, got this message. Then the store event says, oh yeah, I have an old event with 11:04. Then there's line 62 saying, okay, yeah, I'm going to store this because something has really changed. And then I do this store product thing. So I actually have to a new event here. And here it says now amount is 42. Hey, we did it. Very cool. So we have actually done 2 updates in a row, or actually 3 updates, 3, well, times there are new black socks. The first time it was 10. Then we sent the same message again. The second one was ignored. Then we did a new timestamp, 11:05. Therefore, this message was accepted. And the product, the sum of products in black socks has been updated to 42 and the amount time to 11:05. That's cool. And what's going on to come here? Come on. There's more in here. Line 165, there's much more. And it's not scrolling any longer. So what's wrong here? I can't scroll it. And no, I have no idea. So, no, there's something blocking here because this thing here wants to talk to me. And that one's still blocking. Yeah, so what's going on after this? Let's go for the builder service again and get rid of this message in line 56, which is no longer actually 56. However, come on. Go away, please. And have Control C. Oh, there's something wrong with my system. I actually might have. So it doesn't accept my keyboard any longer. That's bad. I'm sorry. I just reboot my system, and that should solve the problem. I have it with my keyboard multiple times, and then So you see me again. I restart this, and so by the way, what is what is the time? Does anybody know? 13:25. So we still have some 20 minutes left. Yeah, great. Hey, I don't even have power connected. That's not good. And is this now working again? Yeah, great. So I wanted to get rid of that one. Cool. Sorry. Here we are again. And I've just commented this guy here in order to get rid of that. And I can scroll in here again. That's cool. Fine. Job backend is running on 3100. I've done a restart on that one. We should actually rerun this thing here, and then we go on through our shop backend test. So we have sent this event here and checked that the amount has sum up to 42. Great. So I'm going to do some more here now. So I'm going beyond just sending the product stored thing. Because I wanted to do some more with the data model of my my shop. So I go for this, what the bean sales does, and she is going to send an add offer thing to the Microshop, and then I want a price attached to my product. So red shoe should be 42, and I'm going to do this in my shop backend test in order to prepare the Microshop backend for the next step where the front end is going to do this in order to have more of the data model. And actually, I would like to go for this step where my data model is actually going to become more complicated. And so I will need to do more in the shop backend, and I ask you to do more in the shop backend too. And I, for now, will just drive this with my shop backend test. So let's have a look. Shop backend test. The next thing I do is I send an add offer for black socks. So I do again a thigh request post to this event thing. It should be actually a command. For some reason, I do it to the event thing, which is probably wrong. We will have to discuss this later on. I don't like to change it by now. So currently I send it to the event backend. It should be the command backend because I am now doing something that is going to be done by the front end. Okay, yeah, it should be the command. And we will have to discuss the difference between command and event soon. And the event type is now an add offer, and the block ID is black socks price. And it's important to not just use black socks again, because if I use black socks and 11 something or whatever, this new event is either going to be rejected because there is an old event where the black socks have been stored, I should actually add the event type to this. Cool. This new event is going to replace the old event, which is not too bad after all. We could actually do that. I'm not sure. So, but actually then after sending a price, getting new black socks would actually override this event. So for some reasons, I thought it would be a good idea to have underscore price attached to the block ID. And actually we'll have to revisit this. Let's see how the example works. You do it at your homework, and then we will discuss next week whether we should increase this scheme and why and where the problems are. Let's just go on with it. So it says 11:14, so it's later than any other thing. However, it's the first of its kind, so everything is fine. It's going to be stored. And the payload is we address the product, black socks, and the price attribute. We do not say anything about the amount. We just address the price. And we expect to get back a product of black socks with an amount still 42, and the price should be attached. Our app controller still gets an event, so there is a handle event operation. And still there should be damn it. You should see the message in our output here. And let's have a look. So this is 10 black socks, 10 black socks, still 1104, still 1104. Here the 32 socks, so now it's 42 and 1105. Okay, and here it comes. Event type is add offer. Black socks, it's 1114. This is a new event. And then we look at what is going to be done about it. So the store event, well, actually it comes to handle event. handle event says, oh yeah, if it's an add offer, I'm going to still ask the model builder service to handle the add offer, which is actually code that I have added to the, we do not yet have it. So this is new code from this week. We didn't have it last week. So we have a new operation handle offer, handle the add offer event, and the event is passed as a parameter. We first try to put it into our event store. As we see, this is going to succeed, so store success should be true. And then we do, if store success, we do create a product patch saying we are looking for a product where event payload.product. Event is this one. Payload product is black socks. And the price is event payload price. Okay, we could actually just have retrieved the payload object. So that would have been fine. Okay, and then we do go for the products model. You still recall that one? That was the product schema having the product, the amount time, and the price, which now has this add property attached to it. So that is going to be handled by the database. We do a find one and update. So the multiplexing, so the ensuring that I handle each event only one time is already achieved by the store event operation. So I can just execute this thing here. I do a find one and update, do an upsert. If this is the first thing, it should be already there. However, yeah, it might happen that the events come in the wrong order. You recall that one. So if the set price or the add offer operation for black socks comes before even black socks have been delivered to the warehouse, or this product stored event comes, this operation would still work, hopefully. Yeah, I'm not sure. Yeah, it would work because it would set product and price. However, it would not set amount and, let's say, amount and amount time, and actually amount and amount time. So if this really would result in the insert of a new product in my database, these should have an amount and amount time, because these are required properties, and I actually could enforce my database to not accept this find one and update without these informations. However, I do not have I have no idea how I do enforce this. I would need to look up the documentation, and because I do not yet enforce it, it's ignored, and MongoDB doesn't care about it currently. So yeah, cool. So it actually is going to set the price, and it does again show me the updated object, which is then locked in at offer line 136. Handle at offer, I don't need that. Handle at offer line 136. So we have now black socks 42. Amount time was 11:05, and at 11:14 the price has changed. So this is another attribute changed by a different event, and because an event is then handled by our builder service, and then it does only change fractions of my object model. We call the payload of the event a patch, because it's actually telling you, please would you change these parts of my whole system. And one of these laws that events may come in any order tell you that two patches shall not overlap. So if there are two patches that both write a certain attribute of a certain object, then the order of appearance would determine which is the final content of this attribute. However, the product stored event is setting the amount and the amount time, and the add offer attribute or event just set the price. So these are different attributes, and though those two patches don't overlap, they just fit together quite nicely, and therefore you can handle them in any order. And this is a critical design issue, and at least at this point in time I did it right, hopefully. And so it works fine for the price. It's not going to work totally fine for the amount, and we will have a longer discussion on that one later on. So it's we still have some 8 minutes. Cool. So we can go through this even longer. However, let's get rid of this one here. That one is no longer needed. Okay. So we have actually handled the price thing here, and actually the test ensured that it did work. Great. And so what we now do is send a place order command. So I'm already simulating the thing when Kali customer sends an order to my shop. And when this happens, so this then I come up with an order object and a customer object attached to the product object. And we will just get these two things done today, and then we are done for the day, for this week. We sent in our backend test, and yeah, by the way, you need the backend test. You guys need to implement these steps too. So we sent a place order event, which is a new event type, which has a block ID, which is an O for order, and then 1121 for the time. That's a bad ID, but I was not looking for a better one. Here again, the timestamp, it's now 1121. I don't need tags any here. Perhaps these are going to go away soon. I have a payload, which is the code or the barcode of the order, 1121. The product that is going to be is ordered, Black Socks. The customer, Kali customer. The delivery address, Wonderland 1. And some state, this is a new order. We will use the state later on. And this is again an attribute which is complicated because it will recreate conflicts between multiple patches. And we will discuss this during next week. Cool. So, and we expect that we get this product placed properly. And so we go for the app controller, and we go for handle event. And there is this place order, which is again a new operation, which we did not yet have last week, but inserted this week. So we go for handle place order, and we do a store event, which is the store event that we have had before, that should deliver a success. Let's have this. We got to place order, and the builder service says, yeah, I did storage. This is this line 62, and then handle place order in line 165 says, yeah, this was a success. So we actually do this find one and update. Come on. Handle place order. It doesn't fit on the screen. Damn it. It's almost there. Store success. We did that one. If store success, yeah, this is really a new event, so we need to handle it. We do an orders model. That's here. So let's go here. I have in my builder service now in the constructor a model for the event store, a model for products, we have discussed that one, a model for orders, I'm showing you now, and there's going to come a model for customers. The order model, come on. So why do you open that in? Oh, not bad. An order has a code, a product, a customer, an address, and a state, and this is it's again my keyboard is gone. Damn it! I hate it. Yeah. My computer is dead. No, I just shut it down and shut it on again. Then my keyboard is there again.
Yeah.
Here we are. Yeah. And there's probably one of the keys actually, but it actually happens when I touch my screen with my fingers, and there's something wrong with this, and I'm sorry about this. So we are back on property. That one should be here. Okay. And I do not store it because then it will recompile and then our debug output is gone. And so let's have it this way. So the order schema. Code, product, customer, address, state, all required. Okay? And because we are just here, let's have a look at the customer schema, which comes up here. Customer has just a name and a last address. No? And so the important point here is that in an order that we store in our database, the customer is just a string. You could have a real reference here, which is something like a pointer within the database. Yeah, however, that is a little bit harder to maintain. And I was discussing with Sebastian and with Max, and they were saying, no, it's okay if you just stick to a string and don't use a real reference here. And could someone should mute her microphone? It's probably, yeah, sorry, thanks, Amel. I use a customer here. There is a design issue here. You could use a reference that would give you more integrity within your database. However, this would require that the customer object already exists in the customer collection before you could set up the order object, because you would, or at least before you could set this attribute here. And this is not very handy. And actually, our application uses barcodes and IDs provided by the user interface, which is yet another design issue to be discussed. And however, references use IDs that are provided by the database. And these two concepts should not be mixed. So we are dealing with our own identifiers, and those are strings. And I use a string here, and we will discuss this later. Okay? And the customer does not have a list of orders. That might be a good idea. However, if you have a list of orders or codes of orders, what you finally would do, you go from the customer collection or customer object to the order collection, and then do a query in the order collection to ask for all the orders that belong to our current customer. And we can already do this with the customer string, and there's no need for the reference from customer to order. And therefore we omit this. If the number of orders for a certain customer becomes very large, such a list of values attached to an attribute becomes somehow a performance problem for Mongo, and so therefore we don't do that. Hey, and I see him nodding, so Sebastian agrees with what I'm saying. That's cool. So I never had this before. So now we have event store product orders customers, and of course you also need to do something in the builder module. Let's get rid of this one. Okay, save it. Let's save this one. And let's have a look at the builder module in the shop backend. There you have this Mongoose module for feature where you actually get access to this collection, or tell Mongoose to set up this module that gives you access to this special collection. we were doing this for event store. I have added this for products, and here you do add orders and order schema. You do some imports for this, and then you can actually deal with that. And we could go for, no, we cannot go for. Let's just rerun the tests. Let's still go through the thing here. In that you see all the functionality, and then we can actually close the session for today. And we were in the handle place order thing here. So once we have actually stored the event and said, yeah, it's a new event, we are handling it, we do a find one and update in the orders model to create a new order object. And we look for the code shall be event payload code. We put event payload, we do an upsert, and these things, and we do a console log, which is actually probably here somewhere now, and I'm not going to go there again. And in addition, we create a customer object. And we connect those two. Well, this connection is already there by the customer thing, but we also want a collection of all our customers in order to be able to query for those customers. And find one and update. So the customer, where's the customer schema? The customer has a name and the last address. So we do a filter for the name, and then we set name and last address, and this is upsert and again new to. Okay, cool. Yeah, it's not too hard. You have those two selection, and you add an object to each of those. And if there is already a customer, or this is the second order for our customer, you reuse the old customer object and just update the last address field. So that's cool. And pretty easy. Okay, we are close to it. Yeah, very close. So here the order 1121 has been placed, and we do wait for the response and check that there is actually an order object where the product is black socks, customer, and state is new order, and we will have to discuss this one here. And then there is another request where we do a query to customers. And this one is again new, so we have to implement and have a look at this. And this is still part of your homework. And so we go for app controller and we go for query. And the key this time is customer. So we go for this app service get query. I'm not sure whether we have had this, either the controller thing, not or the service operation. I didn't think we have it last week. Yeah, I think I have added this. So, and the get query says get the key as a parameter. If the key is customers, so we will have different kinds of queries. And in the warehouse, we were actually answering all the queries with the tags of our events. So now we have an object-oriented data model. So we answer our queries by going to the object-oriented data model. And if we ask for the list of all customers, we go for the model builder service and say, oh, please get the customers. And this does a customers model dot find without any condition. We can actually omit this parameter totally. And this gives you a list. And don't forget the await. And with all the customers in this collection. And so this one is then returned or an error. And here we are. That's it. Here. And so the response body is a list of JSON objects. And so I do expect customer list length is greater than 0. And that one works. And this is basically the functionality that I wanted you to actually achieve. Okay, great. Yeah, I did some more, but we are out of time. So please extend our backend, shop backend, for all this functionality. Have this test that really test all the functionality. Send a product stored event, send an add offer event that asks the price, and send a place order event, and ensure that your object model is going to look like this one. So that you have a product, correct amount of things, have an order, have a customer. Please send one of those events twice in order to ensure that your deduplication really works, and then we are great. Next week, we are going to actually connect the warehouse backend and the shop backend. And that one is a terribly complicated thing again, and then we are done. And then we have actually, well, most of the applications. So then if you have that, 2 weeks from now, we might start to do the shop front end, and we will have some more techniques showing up on that one. And we will still have some discussions on these event wars and how we handle those. And so why we are pretty much on a good shape with what we did so far. And we will see some more problems and have some design issues to be solved, but we are on a very good track. So thank you for your attention, and Maximilian is going to post the details of the assignment in the Discord as every time, every week, and I see you on Thursday with your solutions. Thank you for your attention.